Hello friends, welcome to my YouTube channel. This is my second video on particle physics. Hope you all are able to follow the lessons. Please do comment in the comment box so to make the upcoming videos better. Do like and subscribe. In the first video, we discussed about strangeness. Next, it is conservation loss problems. Directly, we will go to the problem. Once you are able to understand this elementary particles classification, you can do any problems related to this so easily. So you can go through the classification table. That is, elementary particles are mainly divided into two, boson and fermion. Bosons are having integral spin, and for fermion, the spin is half. Boson is further divided into three. They are photon, graviton, and meson. Photon is having spin 1. For graviton, it is 2. And for meson, it is 0. Then is fermion. Fermion, the spin is half. They are mainly divided into two, lepton and baryon. Lepton, we have the members here. And for baryon, it is further divided into nucleons and hyperons. This classification will give the complete idea about the elementary particles. Here, some of the members are mentioned here, that is, in the meson family, there are pi plus, pi minus, pi 0, k plus, k minus, k 0, k bar 0, eta. And what is this number denotes? This is the strangeness of this pion, cation and eta. Strangeness we have studied in the last video. Go through that. And for lepton, it is electron, muon, tau. For nucleon, it is two members are there, proton and neutron. Hyperons we have lambda 0, sigma family is there, sigma plus, sigma 0, sigma minus. And this is cascade 0 and cascade minus. And the last one is omega. The strangeness for omega is minus 3. And for cascade 0, it is minus 2. And cascade minus, it is minus 2. For sigma, we know that the strangeness is minus 1. And for lambda 0, it is also minus 1. The question is, check whether the following high energy processes are allowed by conservation laws or not. For solving these type of problems, that is something related with conservation laws, you must know the three values, that is the charge Q, then baryon number B, and L, lepton number. We will take the first question. P plus P bar gives lambda 0 plus lambda 0. First we will see charge. For P, we know that the charge is plus 1, and for P bar it is minus 1. And we know that for lambda 0, there is no charge, so 0, 0. LHS is equal to 0 and RHS is equal to 0. That means delta Q is equal to 0. Similarly, for baryon number calculation, we have baryon number for P, it is plus 1. For P bar, it is minus 1. And for lambda 0, baryon number is 1, 1. That means LHS is 0 and RHS is 2. That means delta B is not equal to 0. Here it is 2. Delta B not equal to 0. Then we will calculate lepton number. Lepton number we can simply calculate because proton, for p bar, similarly for lambda 0, lepton number is 0. That means delta L is equal to 0. Since baryon number is not conserved here, we can write this is not allowed. Second question is pi minus plus p gives pi 0 plus n. What you have to see first? Charge. For pi minus, we know that the charge is minus 1. For proton, it is plus 1. For pi 0, there is no charge, so 0. For neutron, no charge, 0. That means LHS 0, RHS 0. Delta Q is equal to 0. Next, you have to see baryon number. Baryon. For pi, it is 0. Proton is plus 1. For pi, again 0. And for neutron, it is plus 1 since proton and neutron are baryons. Then LHS is 1, RHS is 1. That means delta B is equal to 0. Then next is lepton number. Lepton number, we know that leptons are not here. So 0, 0, LHS is equal to RHS. Delta L is equal to 0. For this question, we can say that this is a allowed one. But if the question is allowed one is there, but if the question is asked for any strong interaction or weak interaction, you must know what you must be familiar with I3. I3. We will calculate I3 also. For pi minus, it is minus 1. I3 is minus 1. For proton, we know that it is half spin. Then half. Then for pi 0 again, it is 0. I3 is 0. And then for neutron, it is minus half. That means delta I3 is equal to 0. So, when you have to calculate I3 we have to calculate only when all the other numbers, that is the charge, baryon number and lepton number, we are getting it as 0. Then we will check for whether it is allowed in weak interaction or strong interaction. If delta I3 is equal to 0 means it is allowed in strong interaction. Strong interaction. If it is not equal to 0 means it is not allowed in strong interaction. Third question. Neutron gives proton plus electron plus mu electron. First we will calculate charge. For neutron it is 0. Proton plus 1. Electron minus 1. And for mu electron it is 0. That means delta Q is equal to 0. Then next we will calculate lepton number. Lepton number is 0 for neutron. For proton also it is 0. Electron, since it is a lepton, for electron it is plus 1. For mu electron it is plus 1. That means delta L is not equal to 0. Without calculating baryon number, we can directly write this is not allowed. Fourth question is mu plus gives electron plus gamma. First we will calculate charge. For mu plus, the charge is plus 1. For electron it is minus 1. Gamma is not having any charge, so 0. That means LHS is plus 1 and RHS is minus 1. That means delta Q is not equal to 0. In this case, we doesn't have to calculate any lepton number on baryon number. We can directly write it as this is not allowed. Friends, once you are clear with this elementary particle classification, you can do any problem in particle physics so easily. Hope you have understood the way to solve this type of problems. Try to do this problem. In the next video, I will be solving this question first. Thanks for watching.